and welcome back to Season 2 of the Leukopak Lady. I am discussing topics related to the standardization of Leukopaks. Today, I will talk about interdonor and intercenter variability. These are factors that influence differences between donors and collection centers that can result in vastly different Leukopaks collected. And I've been making a list of these factors for quite a while now. These are things I've experienced or learned during my time leading a healthy donor Leukopak collection program, things my developer network experiences, and things other collection programs experience. But this is far from everything that could affect Leukopaks, so I will continue to add to this list. And I won't be able to talk about everything on here today, but I am going to highlight some key items. First, I'll go over some donor-related factors that affect standardization. Intrinsic donor biology. Every donor is different from their genetic background, age, hormones, cell count, and BMI. These factors influence immune cell populations differently, affecting functions, phenotype balance, and proliferation capacity. Immune or health status at the time of collection. Chronic inflammation, recent vaccinations and medications, and nutritional status. These things can influence exhaustion and activation phenotypes and create cytokine imbalance. And deficiencies in certain vitamins can alter cellular responsiveness and proliferation. Lifestyle and behavioral factors. Sleep and stress affect cortisol, which affects lymphocyte trafficking. Regular exercise improves overall immune function, but intense exercise can cause temporary leukocytosis. Smoking, alcohol consumption, diet, and allergies, those factors can create oxidative stress, induce pro-inflammatory cytokines, and affect cellular functions. Collection-related factors can begin to create that intercenter variability. These include pre-collection conditions such as donor preparation, because the hydration status and caffeine intake of the donor influence plasma volume and hematocrit. And every center plans their collections differently. Will they collect to a set total blood volume, time, or cell count? Instrument and parameters have a big influence on consistency between centers. Different instruments create different Leukopak compositions. An anticoagulant ratio, flow rates, and pump speeds, those parameters affect pH, calcium balance, and shear rate, which can lead to lymphocyte death or activation. And plus, the longer the procedure runs, the greater the risk for contaminating RBCs, platelets, and granulocytes in the bag. And those things definitely affect the manufacturability of the cells. Operator and the site itself can also greatly influence variability. The experience of the operator can affect venous access, response to alarms and adjustments, and collection efficiency. SOPs, training, and quality oversight can be different at each center, creating variations in the collection procedures and thus the collected Leukopaks. And key quality attributes set by a collection site, such as how success is measured, what specifications or limits are set, these lead sites to value and meet different collection parameters and goals. And also, post-collection handling can create differences between sites. How long between the collection and the processing steps, such as centrifugation and cryopreservation. Ambient versus refrigerated temperatures, each can affect PBMCs in the Leukopak differently. And shipping conditions, such as the packing, exposure to vibrations, and temperature changes, all those impact the function and the viability of the cells that arrive at the manufacturing facility. Processing and testing are also intercenter factors that can create variability. Processing steps such as centrifugation, mixing, and cryopreservation methods can affect viability, recovery, purity, and the function of cells. Testing differences may introduce the appearance of variability where perhaps little or none exist. For example, lack of flow cytometry standardization in instrumentation, training, and analysis can make comparisons between centers difficult. And also, the thawing of the cryopreserved Leukopaks by the developers can make it seem that the products are different between centers, when it is really likely the result of differences in the technique consistency and the washing and centrifugation steps. And finally, systemic variabilities can create differences. These include how programs define standard and perform characterization, how they manage their data and track donor information, regulatory constraints and gaps, and also just biological randomness, which I'll talk about on next week's episode. I hope to see you then.